Hi guys and welcome. It's Mr. Ghazali here. In this video we're going to study calculus, which is required for the Tahsili course, and we will cover these four topics: limits and continuity, limits, which is part of pre-calculus, and derivatives and integrations, which are basically calculus topics. So let us get straight into the problems. Whilst we're in the problem, I will give you some brief notes. So first we start off with limits, which is direct limits. What is direct limits? Example, when we're finding limit as x approaches -5 of 2x minus 7 over x minus 1, if we directly substitute and see that the denominator is not 0, then we can just directly substitute and get the answer. So let us substitute limit as x approaches -5 of 2x minus 7 over x minus 1. This is a rational function. If I substitute -5 in the denominator, I get -6, right? So it's not 0. That's the reason why we just call it a direct substitution. So we have -5, -1. On top we have 2 times -5, -7, right? So 2 times -5 is -10, minus 7 is -17 over -6. So your answer is just 17 over 6. Let us solve part B. Limit as x approaches 3 of this function here is a mixed function, right, with square root and rational with a fraction. If I substitute 3 in the denominator, I see that I'm not getting a 0, so I can directly substitute. So it's just basically a direct limit. So I'm getting 2 in the denominator. If I substitute 3 inside here, 2 times 3 is 6, 6 plus 3 is 9, square root of 9 minus square root of 8. Okay, square root of 9 is 3 minus square root of 8 is, you can leave it as square root of 8, or you can say square root of 8 is 4 times 2 over 2, and the square root of 4 is 2, so we get 3 minus 2 root 2 over 2. Final answer. I hope you guys are understanding. Let us look at limits involving factoring. Now, how do we recognize that this limit involves factoring? Especially when you get a 0 in the denominator. Example, 4 minus 4 is 0. So if you substitute the x value 4 into the denominator, which is x minus 4, I get 4 minus 4, which is 0. Which means that I need to factor this limit out. So let us factor this out. We say limit as x approaches 4 of, this is difference of two squares, so x squared minus 16 is x plus 4 or x minus 4, or you can think about factoring a trinomial, right, divided by x minus 4. And what we see that we will always get, cancellation happening. So x minus 4 cancels out, we left with x plus 4, and if I substitute 4 inside, I get the answer 8. Remember, the only thing that's remaining is x plus 4. So remember, x approaches 4, x value is 4, 4 plus 4 is 8. So that's my answer. Let us look at part B. If I substitute 2 in the denominator, I do get 0, so I have to factor it out. Limit as x approaches 2, factor this out, I get x minus, remember the product needs to be 6 and the sum needs to be -5. So the product of two numbers is 6, 2 and 3. In other words, -2 and -3, and -2, -3 gives me -5, divided by x minus 2. We see that x minus 2 on the numerator and denominator cancels out. Okay, so we can cancel this out, cancel the numerator out, and if I substitute 2 inside, I get 2 minus 3. Remember, I get 2 minus 3, which is -1. I hope you guys are understanding. Let us look at limits at infinity of rational functions. Now, limits at infinity of rational functions is, we have limit as x approaches positive and negative infinity of f of x over g of x. We have 3 rules. If the numerator degree is greater than the denominator degree of the denominator, degree of the denominator, then the answer will either be positive or negative infinity, right? It depends on what you are substituting. If so, this is case 1. Case 2, if the numerator degree is equal to the denominator degree, then we have an answer which is a constant. I'll show you how to do this. You'll end up with a constant answer. In other words, you'll take the coefficient of the numerator degree, highest degree, and the coefficient of the denominator degree, highest degree. You'll get a constant answer. And the third one is if the numerator degree is less than the denominator degree. In other words, the degree in the denominator is bigger, then your answer will always be 0. Now let us look at these things. So the degree on the numerator is a x squared function, right? So I have a 3 here, and the degree in the denominator is also a x squared function. So be careful, you need to take the highest degree. Because both of them are the same, the answer will just basically be 3 over negative 2. 3 over negative 2. Why? Because the highest power is x squared, so I took a 2, I took the coefficient 3 here. The highest power is x squared, I took the coefficient negative 2. So 3 over negative 2 is my answer. That's why I said when the degree of the numerator, in other words the highest power, when the degree of the numerator is equal to the degree of the denominator, it just becomes a constant. How does it become a constant? You take the coefficient number next to the highest power and the number next to the highest power. So that's how I've got 3 over minus 2. Let's look at the next one. So the degree, the highest degree in the denominator is x cubed, and the highest degree on the numerator is x squared. Because the top is smaller than the bottom, the answer is, what happens? The answer is just 0. Let's look at the last one. I've got a numerator degree which is x cubed and denominator degree which is x squared, and I'm substituting infinity inside here, so my answer will just be positive infinity, right? Because all these, the rest of the values, you consider it as zeros. So remember, you're taking x cubed divided by x squared, you will get x. So if you substitute 3x, if you're trying to substitute, this is what we are doing. We're saying limit as x approaches infinity of 3x cubed divided by x squared is 3x, and if I substitute infinity inside here, I will get infinity as my answer. Okay, so I hope you guys understood these 3 rules and applying it to the various problems here, and I give you all 3 types. Just in case if I put negative infinity here, then your answer would have been negative infinity here. Anyways, let us continue to infinite limits. Infinite limits is just basically directly substituting infinity inside. So remember, you got infinity cubed. Don't put equals. Doesn't make sense to make it equals to its approaches. Right. So if I substitute infinity here, infinity cubed is infinity. 2 times infinity squared is plus infinity, and then plus 1. So if you take infinity plus 1, you will just get infinity as my answer, right? As your answer. Next one, if I substitute negative infinity here, now remember negative infinity cubed is negative infinity because I'm taking negative cubed, right? So your final result should be negative. Then I'm taking negative 2 times negative infinity, right? Negative 2 times negative infinity. I'm getting positive infinity, okay? And then I'm getting a plus 1. Oh, 1 second, this here should be positive. Otherwise you can't say in negative infinity plus infinity is 0. You can't say that. So this should be a plus. So just correct that on your, so it should be plus, let's see. So you got negative infinity cube, which is negative infinity, plus 2 times negative infinity is negative infinity, and then plus 1. So negative infinity plus 1 should give me negative infinity, because you're taking a very large negative number, adding 1. It's not going to make a difference. By adding 1, you'll get negative infinity as the answer, right? So don't forget to correct this. Let's change this into different color. So on your template, don't forget to change this question, right? Otherwise you'll not get an answer. You can't say negative infinity plus infinity is 0. that's incorrect. Next one. We have negative infinity, right? We're substituting negative infinity, so we will get 2 times negative infinity to the power 4, because negative number is to the power even. Remember, negative 1 to the power even is positive 1, and negative 1 to the power odd is negative 1. So remember these rules. That's what we're trying to do here. Negative infinity, you should get positive infinity, and we're taking negative 3 times negative infinity, so another positive infinity. So infinity plus infinity is infinity. I hope you guys understood that. Moving on to evaluating limits from graphs. Use the graph to find limit as x approaches 0. What happens when limit as x approaches 0? What happens when the limit as x approaches 0? So I'm going to approach 0 from the left and approach 0 from the right. So as I see, when I approach 0, I'm getting a value. I'm getting this value here. It looks like the value is 1. Okay, you got to estimate. See, is dead center, so that's negative 1. Not 1, it is negative 1. So I approach 0 from the left and I approach the graph 0 from the right. I found the y value. Remember, when we say limit as x approaches a certain value of f of x, it means you're trying to find the y value at 0. Next one, limit as x approaches negative infinity. What happens when the value goes towards negative infinity? Negative infinity is on this side, like towards the ending value. We see the graph kind of approaches 0. So this is equal to 0. How you know? Because you see the graph is getting closer and closer to the x-axis. So eventually the y value is becoming 0. Looking at the next one, limit as x approaches infinity of f of x. So I'm approaching positive infinity on this side, and I see that the graph keeps on going lower and lower and lower. So it's basically becoming, it's almost about to hit the ground, which means the y value is also 0. Next one, limit as x approaches 2 from the left. Now 2 from the left is this graph here. So remember, at 2 what's happening? This the graph in the first quadrant is going straight up, right? And 2 from the left, the graph is going straight down. So there's like an infinite discontinuity there. So like a vertical asymptote here, right? Because that's what's happening on this graph. We can see that there's like an asymptote at 2. So close to 2, what's happening when we approach 2 from the left? So approach 2 from the left, there's a value 2 here. If I approach 2 from the left, what's the y value? The y value is becoming very large negative. So it's going towards negative infinity. And let's approach 2 from the right. If I approach 2 from the right, the graph is blowing up, is going towards positive infinity. So my answer is infinity. Don't put equals to infinity. You should put an arrow and say approaches negative infinity, and it approaches positive infinity, right? So I hope you guys understood how to find limits from graphs, and this is an example of infinite discontinuity at x is equal to 2. Remember, there is an infinite discontinuity at x is equal to 2, because these values are becoming very large negative, right? Becoming infinite values. Now, how do we evaluate limits from split functions? So we just evaluated limits from graphs. Now we're going to evaluate limits from split functions. So we are given f of x, which is negative x plus 3, and x is less than negative 1. It's nice to draw a number line to make sense of these problems. So we have negative 1 here, right? And to the left of negative 1 is this split function here, negative x plus 3, right? And to the right of negative 1 we have this function here, which is x squared. Now let's see what they are asking us. Limit as x approaches negative 2. Now remember, negative 1 is here, negative 2 is here. So since negative 2 is here, I'm working with the value which is negative x plus 3. So I will substitute negative 2 into negative x plus 3. So when you substitute, put it in brackets. I substituted negative 2 in the place of x. and I'm adding 3. So I have negative negative 2 plus 3 is 5. I hope you guys understood that. Let's move on. Limit as x approaches 0. Now remember where 0 is to the right of negative 1. 0 is working with the function which is x squared. So I'm going to substitute 0 in the place of x squared. So in the place of x I will substitute 0. 0 squared is 0. So that's my answer. Limit as x approaches negative 1. Now limit as x approaches negative 1, okay, the value negative 1 itself is kind of defined. So x approaches negative 1. Yes, we have a problem here. When x approaches negative 1, we have two different values. So we're going to substitute negative 1 on the left function. So this is going to be split up into two parts. Limit as x approaches negative 1 from the left. We're going to choose the left hand side function, which is negative x plus 3, right? And we are going to substitute negative 1 here. Negative 1, negative times negative 1 is 1, 1 plus 3 is 4. And we're going to substitute limit as x approaches negative 1 from the right, which is x squared. And if I substitute x squared, negative 1 into x squared, I will get negative 1 squared, which is equal to 1. We see that these are two different values that limit as x approaches negative 1, right, goes towards. So because it approaches two different values, we say limit as x approaches negative 1 of f of x does not exist. And this value at x equals to negative 1, we call this a jump discontinuity. What is a jump discontinuity? When the limit approaches two different constant values, not infinite values, constant values. So this is a jump discontinuity at x is equal to, so what do we have? So what type of discontinuity is at x is equal to negative 1? So we can say there is a jump discontinuity at x is equal to negative 1, as you can see here. Next one, limits and continuity. For what values of the constant k is the function continuous? Now they're telling us that this is continuous. So now what's the definition of continuity? We have two important definitions for continuity, alright? So let me just write here, make additional notes. Note, right? Continuity. We say mathematically a function is continuous at x is equal to a if limit as x approaches a of f of x is equal to f of a. So the function value is defined at a and the limit as x approaches a exists. So now sometimes when limit is approaching a, you can approach from left and right. So we say limit as x approaches a from the left of f of x is equal to limit as x approaches a from the right of f of x, which is also equal to f of a. Now remember, when we have a split function with greater than and less than, we usually go and use the left and right hand side function, like in our cases that are presented below. So in these cases, if these two conditions are satisfied, right, we say the function is continuous at x is equal to a. For what value of the constant k is the function f of x continuous at x is equal to 1? So we're going to substitute 1 from the left, right? I'm just going to do it quickly, not really writing it in limit notation. If you write it like that, so okay, let's just write it mathematically. So we say limit as x approaches 1 from the left must be equal to 1 from the left. I'm going to choose which function? 1 from the left will be kx squared plus 2x, right, is equal to limit as x approaches 1 from the right of k over 2 minus 5, because 1 from the right will be this function here. Now I'm going to substitute, it should have been kx, yes, correction here, put a x here, kx, not kx, 5x here. So just correct that in your template. Now continuing here, if I substitute 1 If I substitute 1 in the place of x, I get k plus 2, because 1 squared is 1, 2 times 1 is 2, and this is k over 2 minus 5. Now we solve for k. Bring the k over 2 to the other side. Remember, half k minus half k is equal to minus 5 minus 2. So k minus half k is half k is equal to negative 7. Now if I multiply both sides by 2, I will get k is equal to negative 14, and that's my answer. So the value of k being equal to negative 14 will make this function continuous at x is equal to 1. Next one. For what value of the constant k is the function f of x continuous at x is equal to 3? So I'm just going to do should be 2, not 3, right? So I'm going to do 2 from the left equals 2 from the right. Okay, now I'm going to substitute 2 from the left in this function here. Limit as x approaches 2 from the left, right? Let's write it properly. Mathematically this should be incorrect. Limit as x approaches 2 from the left. 2 from the left I would choose kx squared, and limit as x approaches 2 from the right. 2 from the right I will choose 4x plus 3, right? And I want to solve for k. Substitute 2 inside here, you get 2 squared, which is 4. So 4k is equal to, substitute 2 in the place of x, we'll get 8 plus 3. So k is equal to 8 plus 3 is 11, right? So k is equal to, dividing by 4 both sides, I will get 11 over 4. I hope you guys are understanding. Let's move on to the next one. For what values of constant k is the function continuous at x is equal to 0? So we'll say limit as x approaches 0 from the left. 0 from the left I will choose k e to the power x equals, remember e is a transcendental function like pi. It has a value 2,718. Limit as x approaches 0 from the right will be x squared plus k. Okay, one second, should be, just correct this, it should be 2k here, just looking at the function, right? Make it 2k. Now we solve this problem here. Substitute 0 inside here. If I substitute 0 in the place of e to the power 0, anything to the power 0 is always equal to 1, so we just have k. If I substitute 0 in the place of x, I will get 0 plus 2k, right? So I have take this 2k over, I have negative k is equal to 0. This implies k is also equal to 0. Yeah, so that's my answer, k equals 0. Moving on to the next one. Find the derivative of. Now how do we find the derivative? We have a derivative rules. Let's look at the quick rules of derivatives before we solve these questions. So first we have the power rule, derivative rules, right? What are derivative rules? We have y equals, let's do the power rule first. Number 1. What's the power rule? Now before we learn about the power rule, we need to know two important things of radicals. X to the power m, nth root of x to the power m is x to the power inside over outside m over n, and the second rule is negative exponents. Like if I have a to the power, you need to convert to negative exponents, right? Example, if I have a constant k over x to the power n, then that will become k x to the power negative n. These two rules are important. So now in power rule we have y equals c x to the power n. So the derivative the derivative is taking the product of the power and the constant, so Cn x to power, and taking away 1 from the power, n minus 1. That's the power rule. Next one is the product rule. Product rule says if I have y equals the product of two functions, f times g, f of x times g of x basically, so I'm just going to write f times g, right? Then the product rule says differentiate the first, leave the second, plus differentiate the second and leave the first. Differentiation means derivative. Third one is a quotient rule, right? Quotient rule has a division. So if I have y equals f over g, f function over g function, quotient rule says the derivative. To find the derivative of f over g, we say f prime g minus g prime f, right? And remember, there is a g squared. You have to square the denominator. So those are three rules. There's one more, which is kind of derived from chain rule, which you just need to know the formula for tahsili. The next one is a radical rule, right? Especially just a radical rule with the square root. So if I have the square root of f of x, the derivative becomes, find the derivative of this, f prime over 2 root f. That's it. Okay, so find the derivative, put it on the numerator, and 2 square root f, right? So that's a radical rule, only with the square root, not with the cube root. Now let us look at these problems. Find the derivative of, we want to find the derivative of a constant, right? So to find the derivative of this, we can go quickly add the x to the power 0, right, next to this. Now to find f prime x, remember 0 times negative 6 is just 0, so we don't care whether you're going to take out 1 from the power or not. The answer is just 0. 0 times anything is 0. But if you do the full rule, is 0 times negative 6 is 0, x to the power 0 minus 1, negative 1, and you can see 0 times x to the power negative 1 is just 0. Moving on to the next rule, I want to find g prime x. So g prime x, this is already in power function, right? So 3x squared, 2 times 3 is 6, take away 1 from the power, so you get x to the power 1, plus, remember, put 1 there, 1 times 5 is 5, x to the power 1 minus 1 is 0. Always reduce the power by 1. Now what's the power next to 7? Is x to the power 0. 0 times negative 7 is plus 0. Now let's simplify this. Simplifying this will give me an answer, neat answer, right? So we're going to get 6x plus 5. That's it, because x to the power 0 is already 1, right? Plus 0, that's out. You can go and say x to the power negative 1. 0 times x to the power negative 1 is 0. So you got 0 here, you got x to the power 0, which is 1. So 6x plus 5. That's it, that's your answer, 6x plus 5. Solving C, we want to find dy dx of this function here. Dy dx of this function, now it's already written in power form, so we're just going to multiply. So we will find dy dx, the derivative is the same thing as saying y prime. Okay, we will take minus 4 times 5 over 2. Minus 4 times 5 is minus 20, divided by 2 is minus 10. So x to the power was 5 over 2 minus 1, which is 3 over 2, plus 8 times half is 4, x to the power, reduce half by 1, so you'll get 1 half minus 1, which is negative half, plus, remember, derivative of constants is just 0, because you write x to the power 0 there, same concept as before and the previous problem, right? So now I will rewrite this as negative 10 x to the power 3 over 2 plus 4. X to the power half means it goes down, it's a negative exponent, right, which is negative 10 x to the power 3 over 2 plus 4 over the square root of x. Remember, x to the power half is square root x, right, because inside is 1, outside is 2. I hope you guys understood that. Now remember, x to the power 3 over 2, you can even simplify that. You can also simplify this. You can write this as negative 10x times x to the power half, right? Now x to the power half is square root of x, so this is negative 10x square root of x. Why did I break it down like this? If you want to know what this the full form of this is, to try and understand this better, that's what it is. 1 plus half is 3 over 2. Can you see? So I broke this x to the power 3 over 2 into x to the power 1 times x to the power half. So that's what I have, right? So you can also say this is the answer for this, plus 4 over root x plus 4 over root x. You can go continue into that form. Next one. Next problem is not power rule. We applied power rule in the previous 3 problems. This one is product of 2 functions, so I have f and I have g. So to find h prime x, the derivative, I will find the derivative of the first function, which is 3x cubed minus 1. So 3 times 3 is 9, 9x squared. The derivative of negative 1 is 0. Leave the second function, which is 5x squared plus 2, plus find the derivative of the second function, which is 10x, and leave the first, which is 3x cubed minus 1. So differentiate first, leave the second, plus differentiate the second, leave the first. Now we will simplify. 9 times 5 is 45, x to the power 4, 45 x to the power 4, 9x squared times 2 is plus 18x squared, plus 10x times 3x cubed is 30x to the power 4, 10x times minus 1 is minus 10x. Now we will write it in polynomial order, right? To simplify this problem, we write it in polynomial order. 45x to the power 4 plus 30x to the power 4 is 75x to the power 4. 18x squared, that's it. 18x squared minus 10x, that's it. That's my answer. I hope you guys are understanding. If you're not understanding, don't forget to leave comments in the comment section below. Let's look at the next problem. Next problem is quite simple, right? Again, we have the product of 2 functions, so we can use a product rule here. So we say k prime x, right? 3x minus 4, right? We have 3x minus 4. So find the derivative of 3x minus 4, we get 3. Leave the x minus 1, plus find the derivative of x minus 1. If you find the derivative of x minus 1, derivative of constants is 0. We got a 1 here and a 1 there. 1 times 1 is 1, right? And x to the power 0 becomes 1. And leave the, so derivative of x is just 1. And leave the second function, which is 3x minus 4. So what I have, 3x minus 3 plus 3x minus 4. So 3x plus 3x is 6x minus 7. Is there another way to do this problem with a product rule? Yes, there is. You can go and open up this function k of x, right, which is equal to, let me use another derivative notation. Sometimes they also use this big D of x. It means derivative with respect to x of this function here, 3x minus 4 into x minus 1. So how do I solve this? I can go and expand this. The only time I drop the dx is when I find the derivative. This is another way to find the derivative. See what I did? I transformed this function into this. So the capital dx means find dy dx, right? Find the derivative of this function. So 3x squared, right? 3x times minus 1 is minus 3x minus 4x plus 4. I'm just expanding this. These are equivalent. I didn't differentiate as yet, right? Now 3x squared, right, minus 7x plus 4, right? So now if I differentiate, 2 times 3 is 6x, right, and then minus 7. So I end up with the exact same answer, right? As you can see, I used the product rule here. What rule I use? I use product, right? How I know? Because that's f, that's g. This is f prime g plus g prime f. That's what I used here. And over here I use the power rule, right, by opening up the entire products. Moving on to the next one, I have a quotient, so I will apply quotient rule here. Let's find dy dx. So we'll say dy dx is equal to, remember the top function is f, the bottom function is g. I'm finding f prime now, so I will find the derivative of 5x plus 1 is 5, leave the bottom, x minus 2, subtract, differentiate the bottom, derivative of x is 1 as I explained before, leave the top, which is 5x plus 1, all over x minus 2 squared. You have to square the denominator. Now if I simplify the top, remember 5x minus 5x, 5 times x is 5x, minus 5x is 0. So remember I've got 5x minus 10 minus 5x plus minus 5x minus 1, wait, minus 1 all over x minus 2 squared. So what do I have here? I've got 5x minus 10 minus 5x minus 1. So I've got 5x minus 5x cancels out, right? There's a cancellation happening here, and then minus 10 minus 1 gives me minus 11, negative 11 over x minus 2 squared. Okay, I hope you guys understood that. Moving on to the next problem, also a quotient rule. Right, so I've got n of x, so I'll find n prime x. Okay, n prime x, or you can also say this is dn dx, the derivative of the function n with respect to x, right? So to find the derivative of the top, I've got 10x, right? Our derivative of constant is 0, leave the bottom, subtract, differentiate the bottom. Wait, let me change this function. You keep on getting 1 here. Let's just put a 2 here. Okay, so minus 2, derivative of x is 1, derivative of 2x is 2, right? And leave the top, which is 5x squared. Just make it 3 there, right? So 5x squared minus 3, leave the top, all over denominator squared. If I square the denominator, I will get 3x minus 5 all squared. Let's simplify. 10x times x is 10x squared minus 50x minus 15x squared plus 9 all over 3x minus 5 squared. Now if I simplify this in polynomial order, 10x squared minus 15x squared is minus 5x squared minus 50x plus 9 all over 3x minus 5 all squared, and that's my answer. I hope you guys understood that. Let's look at h. Now h follows the special rule of differentiating radical functions, so I'm going to find p prime x, right? P prime x is, find the derivative of this, right, which is 5, leave it on top, 2 square root 5x minus 1. Okay, make it plus 1 because it will not work out, right? So make it plus plus. Right, so let us simplify this. This is now equal to, one second, yeah, so now this is equal to 5 over 2 square root 5x plus 1. We will substitute p prime 0. The derivative is done, okay, because we differentiated the inside, we put it on top, is over 2. Remember the 2 is always fixed, is because of the square root, right? And put the function down. Now this implies p prime 0. If I substitute 0 inside here, 5 times 0 is 0, and I've got 1 there, 5 and the square root of 1 is 1, so the answer is just 5 over 2. I hope you understood that. It's just directly substituting 0 inside this derivative function. Now remember, what does the derivative represent? The derivative represents a slope function. Okay, that's what it represents. It's a slope function. So I'm basically asking you for the slope. What's the value of the slope at 0, right? Because the graph of this looks like a square root function right? The graph of this is a square root function, and it's like starting here and going there, right? And I'm asking you for the slope at 0. What's the slope at 0? So you got like a line going tangent to this. The slope at 0 looks like it's like 5/2. It's like a positive slope. That's what I'm asking you for, the slope of a line at 0. Next one, a similar problem like this, just the function is a little bit more complicated. Okay, just the function is a little bit more complicated, but no issues, we can apply the same formula. So we'll say, what is f prime, let's say q prime x. Q prime x, find the derivative of the inside. So you got 2 times 3, which is 6, take away 1 from the power, so 6x minus 2 all over 2 square root of 3x squared minus 2x plus 7. Now we're trying to find q prime 1. Q prime 1 is finding the slope of this tangent line at 1, right? The slope of the tangent at 1. Now let's see, we're going to substitute 1 in the place of x. So I have 6 minus 2, which is 4 over 2 square root. I'm going to substitute 1, so I've got what is this, 3 minus 2 plus 7. So I've got 3 minus 2, which is 1, 1 plus 7 is 8. Okay, now square root 8 is 2 root 2. Remember, square root 8 is equal to square root of 4 times 2, and the square root of 4 is 2, and the square root of 2 I can't find, so I will replace 8 with 2 root 2. So I've got 4 over 2 times 2 root 2, and now you can see 4 cancels out with 2 times 2, which is 4. So what's my answer? 1 over square root of 2. I hope you guys understood that. Next one, slope and tangent line. As I explained, slope is the derivative function, represents a slope. So if you substitute values inside, the derivative function represents a slope function. So if you substitute values inside the slope function, what do you get? You get the slope of the tangent line. So this is a function that we have. We need to rewrite this function. When to find the slope, find an equation for the slope of the line tangent to the curve. So we'll find the slope equation, right? So y is equal to 2 x to the power inside over outside, 2 over 3. So what's dy dx? This is the slope equation, right? So dy dx is a slope equation, which is equal to 2 times 2/3 is 4 over 3, x to the power, take away 1 from 2 over 3. So 2 over 3 minus 1 is negative 1/3. And we want to see what part B is saying, find the value of the slope at x is equal to 1. So we want to know what's the value of the slope at x is equal to 1. Right, so if I substitute 1 to the power negative is just 1. So the answer is just 4 over 3. Let's look at the next one. We want to find the slope here. So remember, it's a square root function, it's a radical function. So to find dy dx, which is the slope, we'll say find the derivative of the inside, which is 2x minus 5 over 2 square root x squared minus 5x, and at x is equal to 1 I will get the slope. Why you substitute 1? Because they want to find this. Remember, this is a slope function. Dy dx is a slope function, right? And now if you substitute 1 inside the slope function, you should get the slopes. Let us substitute 1 here. 2 minus 5 is negative 3 over negative 3 over, let's see, 2, and what is substituting negative 3 there, right? I have 9 minus, sorry, I'm substituting 1 inside here. Again we have a problem. If I substitute 1, I will get 1 minus 5. Should have substituted negative 1. Alright, make it plus here as well, because you will end up with square root of negative, which does not work. Okay, so that should be plus 5. Let's redo this problem. We will substitute. So again, remember I changed this one here. So I'm going to put x squared plus 5x. So I have 2x plus 5. The derivative of the inside is 2x plus 5 over 2 square root of x squared plus 5x. So I took this function down with the 2 outside, right? So now I'm going to substitute 1 inside here. 1 inside here, so I will get 2 square root of 1 plus 5, which is square root of 6, and on the top I will get 2 plus 5, which is 7. So I just have 7 over 2 root 6. That's it. Leave your answer like that. Next one, maximization, minimization, and critical values. To find the critical values, you'll find the derivative of the function, alright, f prime x is equal to 0. When you solve these, you might find x1, x2. These are called critical values. The solution to the derivative function is called critical values. Right. Now when you substitute the critical values, you get y values, right? And you'll need to compare between the two values and see which one gives me max or minimum. So that's what we're going to do. So concept of maximization, minimization, and critical values is basically to find the maximum, you need to find f prime x is equal to 0. To find the minimum, same thing. Right, f prime x is equal to 0, and compare y values. Need y values, right? And critical values, you just say f prime x is equal to 0. Solve that equation and get x values. So let's do that here. Now solving this, we want to find the derivative of this. Remember, x cubed over 3 is the same thing as saying 1 over 3x cubed minus 3x squared, because we want to see constants and powers. That's why I'm writing it like this, plus 8x plus 4. Now let me find the derivative of this. So f prime x is now equal to, what's 3 times 1 over 3? 1. So, and reduce the power, x squared minus 6x plus 8 is equal to 0. Now I'm going to solve this equation. We have x and we have x is equal to 0. Substitute product of two numbers is 8 and its sum is negative 6. So negative 4, negative 2. So x is equal to 4 or x is equal to 2. So I have two answers. So these are the critical values. Right, we want to find the maximum and minimum value. So we need the y values. So we will substitute 4 inside the original function. So we need to go and find f of 4 is the y value. F of 4 is the y value at 4, right? So we need to find this, okay? F of 4 is a y value, so 4 cubed is 64 over 3 minus 3 times 4 squared. 3 times 16 is 48. 8 times 4 is 32 plus 4. So that's going to give me 64 over 3 is 21 and 1/3. And this will give me 36. Minus 48, so that's going to give me minus 12. Okay, 21 and 1/3 minus 12. So 21 minus 12 is 9. So I'm getting 9 and 1/3. In other words, I'm getting 9 times 3 is 27, 28 over 3. Okay, that's my answer here. Let's check if this is correct. Substitution, 8 times 4 is 32. Yes, so I have a value which is 28 over 3. I have a y value. Now let's try to find the y value at 2. Okay, so let me put all these calculations in the side here, because that's for this one. Alright, and now I'm trying to find the y value at 2. So I want to find f of 2, which is equal to the second y value, right? Alright, so that's y1. So for the second y value, I've got 2 cubed, which is 8 over 3. Then I've got 2 squared, which is 4 minus, so minus 12. Remember, I'm substituting into the original function. 8 times 2 is 16 plus 4. right? So I have 8 over 3, which is 2 and 1/3. I've got 20 minus 12 is plus 8, right? So I've got 10 and 1/3. So that's basically 31 over 3. 10 times 3 is 30. 30 plus 1 is 31. 31 over 3. I hope you guys understood that. Sorry, that's 2 and 2/3 is 8 over 3, not 2 and 1/3. 2 and 2/3, so you should get 32 over 3. Okay? 20 minus 12 is 8. Right, next one. Next problem, same. Find the critical value. Now we need to figure out which one is minimum and which one is maximum. Right, so let's see. So 28 over 3 is definitely the minimum value. Right, and 32 over 3 is a bigger value, so this is definitely a max value. Max value is 32 over 3, minimum value is 28 over 3. So there is a big difference between critical points, critical values, and maximum and minimum values. Find the critical values of the function. So we'll find f prime x, and we'll just stop at the x value. So x cubed is 3x squared, because the derivative 3 times 1 is 3, reduce 1 from the power, minus 12x plus 9, which is equal to 0. We need to write this in standard form. We can divide the entire equation by 3. So we got x squared minus 4x plus 3 is equal to 0. Now we can factor it out. We got x minus 3, x minus 1, which is equal to 0. So x is equal to 3 or x is equal to 1. Now if you remember, these are the critical values. There are two critical values, which is 3 and 1. Critical values are 3 and 1. Now if you remember from pre-calculus, a graph of this cubic function looks something like this, right, with minimum and maximum here. Now remember, these are the x-axis. So at x is equal to 1, you're definitely going to have 1 on this side, and you're going to have 3 on the right and 1 on the left. So remember, the maximum occurs at x is equal to 1. We don't know what the maximum y value is. You can substitute 1 inside here and figure out what's the maximum, and substitute 3 inside this function to figure out what's the minimum occurs here, and we don't know what the y value is. You can find the y value by substituting 3 inside here. So remember, the minimum occurs at x is equal to 3 and the maximum occurs at x is equal to 1. I hope you guys understood that. Right, let's move on. Now we move on to integrals. Integrals has a very basic concept. We find the integral of x to the power n dx, right? You add 1 to the power, right, and you divide it by the exact same power, and you add a c. Now what if there was a constant k there? You don't touch the constants. That's it. This is called the power rule for integrals, right? And I think that's the only rule that you need for tahsili. Let's continue. Let's solve these problems. Find the integral of. To find the integral of f of x, integral means antiderivatives, right? You're working in reverse. So to find the integral of this, we use this integral sign, which is 3x squared minus 5x plus 2 dx. Now let's follow these rules. Keep the 3 as it is, add 1 to the power, x to the power 3 and divided by 3. Okay, just need some space here. Right, now same, negative 5, add 1 to the power 2x, so to the power 2 divided by 2. And what about the next one? Is x to the power 0 next to that, right? So I'm going to leave it as plus 2 x to the power 1 divided by 1 and add a constant, because the derivative of constant is a 0. You have to add constants at the end. Now 3 and 3 cancel out, so I've got x cubed minus 5 over 2x squared, neatening this thing up, over 2x plus c. That's my final answer. Now how do you know whether your answer is correct or not? you find the derivative of this and make sure you get 3x squared minus 5x plus 2. Let's check. 3 times 1 is 3, take away 1 from the power, so 3x squared. 2 times minus 5 over 2 is minus 5x, there's it here, and plus 2, there's it here, and derivative of constant is 0, so it works perfect. Let's look at the next one. This is pretty straightforward. Just add 1 to the power and divide by the same power, so x to the power 6 over 6 plus c. So I can rewrite it as 1 over 6 x to the power 6 plus c. I added 1 to the power and I divided by the same power. Quite simple. Next one, again same story. We got 3 x to the power, add 1 to the power, you get negative 1, divide by negative 1, plus 6, add 1 to the power there, you get negative 4 over negative 4 plus c. Now 3 divided by negative 1 is negative 3, x to the power negative 1 goes down, 6 divided by negative 4, 6 divided by negative 4 is negative 3 over 2, x to the power 4 goes down, right, plus c, and that's my final answer. I hope you guys understood that, right? Remember, I divided by 2 here, divide by 2 there, you can do simplification. Next one, I can't really integrate it like this in this form, so I will rechange this into power rule form. 7x to the power 4 minus 5x to the power negative 3 dx. So I have 7x to the power 5 over 5 minus 5x to the power negative 2 over negative 2 plus c, because I added 1 to the power. When you differentiate, you subtract. When you integrate or antiderivative, you add 1 to the power. Now I've got 7 over 5 x to the power 5 plus 5 over 2 x squared plus c. Remember, x to the power negative went down, so I wrote it like this. I hope you guys understood that. And the last problem, remember we got square roots and stuff, so please write it in power form. It's quite simple. So if I find the integral of 2 x to the power half minus 3 x to the power negative half, you know we have x to the power half down, if you bring it up it becomes a negative power dx, right? So I've got 2 x to the power, add 1, we'll get 3 over 2 divided by 3 over 2 minus 3 x to the power half divided by half plus c. Now let's see what we get. Now what is 2 divided by 3 over 2? Yes, question, what's 2 divided by 3 over 2? Remember to keep change flip, right? So 2 times 2 is 4, so I will get 4 over 3. 2 divided by 3 over 2, 4 over 3 x to the power 3 over 2. Subtract, what's 3 divided by half? 3 times 2, keep change flip. 3 times 2, you need to flip the half, so you will get 2 over 1. So 3 times 2 is 6. X to the power half plus c, and that's your answer. Now what happens when we evaluate the definite integral? We don't put a plus c, okay? There's no constants at the end. So if there's no constants, what do we do? Example, integral of a to b of f of x dx. We'll get a bigger function, the antiderivative function, right? From x is equal to a to x is equal to b. We will substitute the upper value inside, so we get f of b minus f of a. Sometimes this is called the fundamental theorem of calculus, right? Where we actually get a value, and this here represents integral from a to b of f of x dx represents an area under the curve. So this is how you calculate areas, right? So this here actually has a geometrical meaning. This integral actually has a meaning where you can apply it into the real world, is to find area under curves and area under graphs. Now if I integrate 2x minus 3, if I integrate 2x minus 3, I will get 2x squared over 2 minus 3x. Remember the integral of 3x. Why 3x? Because this is x to the power 0. I just added 1 to the power and divided by the same power. Add 1 to the power, divide by the same power. Now this is from x equals 1 to x equals 2. Now we need to simplify the inside, so we can substitute. So if we simplify the inside, we're getting x squared minus 3x from x equals 1 to x equals 2. If I substitute 2 inside, right, if I substitute 2 inside, I will get 2 squared, which is 4. Substitute 2 in the place of x. Remember, I'm substituting the upper value inside this antiderivative function. So minus 6, and subtract f of a, substitute 1 inside here, so I get 1 minus 3, right? So 4 minus 6 is negative 2, right? And 1 minus 3 is negative 2. 1 minus 3 is negative 2 and negative, so you'll get positive 2. So what's the answer? 0. So this here basically represents like a net change, net area, because the way the graph is structured. Moving on to the next one. Next function, I have integral 0 to 1. Integral 0 to 1 of this function here. Let's solve this. So I have x cubed over 3 plus 2x squared divided by 2 minus 3x. So I've integrated this. I added 1 to the power divided by the same power, left the 2, added 1 to the power divided by the same power, 3x from 0 to 1. It means x equals 0, x equals 1. Now I need to simplify this. I've got 1 over 3x cubed plus x squared minus 3x, 0 to 1. So if I substitute 1 inside here, I will get 1/3, right? So I'm going to remove the square brackets and just put round brackets here, substituting 1 inside. So 1 cubed is 1, so 1/3 plus 1 minus 3, substitute 0. If I substitute 0 inside here, I just get 0. Right, so my final answer here is 1/3 plus 1, 1 and 1/3. Wait, I have 1/3, 1 over 3 minus 2 over 1, right? No need for brackets here now, because 1 minus 3 is minus 2. So remember, I'm going to multiply the minus 2 times 3, right? So 1 over 3 minus 2 times 3, so 1 minus 6 is minus 5 over 3. Yeah guys, geometrically this here is basically representing area under the curve. Because this is negative, it's representing a net change area. It's like a net area, because remember, when you find the area under the graph like this, area is supposed to be positive, but because the way this is sketched, remember this is a parabola, this is a quadratic function with y-intercept being negative 3, and I think the intercepts are minus 3, no, plus 3, so it will be negative 3 and 1. So geometrically what this is representing is an integral from 0 to 1. So you've got a function like, the turning point should be somewhere around there, the turning point, the y-intercept is there, the y-intercept is negative 3, the turning point should be somewhere around here, right? That you can figure this out by using minus b over 2a to find the turning. Now you are finding the integral from 0 to 1. So from 0 to 1, you can see the area is below the x-axis. That's the reason why you're getting a negative answer. Let's continue. Area under curves. This will explain geometrically. Find the area under the curve of x squared minus 2x. Now x squared minus 2x is, let me just give you a quick sketch of this function so you can understand this better. X squared minus 2x, I can factor this graph as x minus 2, x into x minus 2. So x-intercept is 0 and 2, and it's a happy graph because it's positive quadratic function. right? So it's something like this, right? And the graph is basically turning at 1. We're not really interested in at the turning point here. We're interested in from 2 to 4. So I want the area from 2 to 4. So it's no way here. I want the area from 2 till 4. So basically this graph continues in that direction. So I want the area from here. That's what. So I should get a positive answer. Let's check. So area is equal to integral from 2 to 4, right, of x squared minus 2x dx is a to b f of x. Remember, area formula is integral a to b of f of x dx. So I've got x cubed over 3 minus 2x squared over 2, right, from 2 to 4. Now I will resimplify this. That's 1 over 3x cubed minus x squared from 2 to 4. I hope you understood how I integrated this. I left the minus 2, I added 1 to the power, and I divided by the same power. There's no c. Right, now if I substitute 4 in the upper value, right, so 4 cubed is 64 over 3 minus 16, right? Subtract 2 cubed is 8. I got 8 over 3 minus 2 squared is 4. So 64 over 3 minus 8 over 3, I should get 56 over 3 minus 16 plus 4 I should get is minus 12. I hope you guys are understanding, and we need to simplify this, right? So 56 over 3 should get 18 times remember 18 times 18 and 2/3. 18 times 3 is 54, 56, yeah, minus 12. So I've got 18 minus 12 is 6 and 2/3, 18, 20 over 3. I should get 20 over 3 as my answer. I'll be 20 over 3 units squared, square units. Alright, so moving on to the next problem. Remember, there's no calculators allowed. Integral from 0 to 4. Alright, so we want to integrate 2x minus 4. So graphically, what this here represent is a triangle, right? It's a line. We're trying to find the area under the line of 2x minus 4. It's a straight line. It's cutting through minus 4, right? It's cutting through minus 4, and the x-intercept is 2. So it's quite a steep line, right? So it's cutting through minus 4 and x-intercept is 2, and I want to find the area from, basically I want to integrate 0 to, I want to integrate from 0 to 4. So obviously you will find that this area will cancel out with this area here. So if I use geometry to solve this, I'll say area is equal to area 1 and area 2. You can see this one is smaller and this one is bigger. So I will have half base times height over here. We don't know what the height is, so substitute 4 inside here. So height is 4 and 4. Because if I substitute 4 here, 2 times 4 is 8, 8 minus 4 is 4. So the height is 4 there. So I will take half. What's the base from 2 to 4? The base from 2 to 4 is 2, and the height is also 4. Subtract. Okay, so basically I'm going to get 0 as my area because both cancels out. I can see how base times these two triangles are identical. The way I drew it is a bit off, so just excuse that, right? Make sure your diagram is kind of like to scale. Wait, if you draw it to scale, then you'll find that that's not the exact values. 4 should be like kind of like closer. So that's the reason why these things are cancelling out. So you should get 0 because this one and this one is, this is positive area and that's negative area. So your answer should be 0, right? So let's see. Area is equal to integral 2x minus 4 from 0 to 4. So in physically, what this here should represent is, if this is a velocity time graph, right, the displacement, when you integrate you get the displacement should be 0. Now let's see if the answer is actually 0. So 2x squared over 2 minus 4x, I've integrated this function 0 to 4. If I substitute, let's simplify this further, x squared minus 4x, right, 0 to 4. Now if I substitute 4 here, I'm getting 16 minus 16 minus 0. So yes, I am getting an answer of 0, which I explained geometrically. Let's look at the last one. Find the area bounded. Find the area bounded by the curves. So this is like a higher level order thinking question. Find the area bounded by the curves. So I want to see, what does bounded mean? So area bounded basically means that I want to find the area between two curves. So I have a quadratic function y equals x squared, right, and I have a straight line function, right. Now we need to figure out where's the points of intersection. I can see the point, so this is the area that I want to find. Okay, so there's a quadratic function, the quadratic function from 0 to 1. Why 1? Because those are the points of intersection, 0 to 1. How do we find points of intersection? We can say x squared is equal to x, x squared minus x is equal to 0, x into x minus 1 is equal to 0. So x is equal to 0 or x is equal to 1. Those are the points of intersection. We can see the straight line function is higher up, right? Because if I substitute half inside here, I will get half and half, right? And if I substitute half in the x squared function, I will get half and quarter. So between 0 and 1, let's call it this f graph and g graph. Between 0 and 1, the f graph is at the bottom, so the g graph is on top. So remember, this is the g graph and that's the f graph. That's the f graph, right, the quadratic function. So what we see here, so how do we find the area? We're going to take area under the curve of so the area is equal to integral from 0 to 1, right? We're going to take the top function, which is a straight line function, which is x dx, and subtract the bottom function, integral 0 to 1. What's the bottom function? The bottom function is x squared dx. Now you notice that we got 0 to 1 here and we got 0 to 1 here. So we can just take x minus x squared and combine it into a single integral, x minus x squared dx. Now you don't have to do that, you can work this out separately, and get the answer. Otherwise, if you do this, much better. Now we have x squared over 2, integrating this you will get negative x cubed over 3, because there's no constants here, right? And from 0 to 1, if I substitute 1 inside here, I will get half minus 1/3, and subtract 0, because if I substitute 0, I will get 0. Now simplifying this, what is half minus 1/3? Let us simplify this. Remember, the first one is times 3, common denominators, times 2 times 2. So I get 3 over 6 minus 2 over 6. I will get 1/6 square units, right? And that's my answer. That's my area bounded, right? So guys, I hope you are understanding all this, right? Let's move on to the next question. Integral equations. Simple, integrate and solve the equation. That's it. Solve for k. So we have from k, let's simplify this. We have k, leave the k as it is, add 1 to the power, x squared over 2 from 0 to 3, right, is equal to 27. I will substitute 3 inside, so 3 squared is 9. I got 9 over 2k, substitute 0 inside, so minus 0 is equal to 27. Upper boundary minus lower boundary. Now I will solve this, right? So I would say 27 times 2. Remember, I'm multiplying, so 27 times 2, or divide both sides by 9. So I've got half k is equal to 3 because I divided by 9 both sides. 27 divided by 9 is 3. 9 divided by 9 is 1. So there's it here. So k is equal to 6. Therefore k is equal to 6. I hope you guys understood that. The next part, which is part B. So I've got x cubed, we're almost ending, guys. Alright, so x cubed divided by 3 minus 2kx. Remember, 2k is a constant. So what's the variable next to the constant? X to the power 0. I added 1 divided by 1, right? So something like that. From 0 to 2 equals negative 10. Now if I substitute 2 inside the function, I will get 8 over 3. Substitute 2 here, minus 4k, minus, substitute 0 in the place of x, so 0 minus 0 is equal to negative 10. Now solve for k. So I will take 8 over 3 to the other side. I will get minus 10 minus 8 over 3 equals negative 4k. Okay, now I need to divide everything by negative 4. We're almost there, guys, right? So negative 4k is equal to, remember this one is quite simple. We're going to just make it over 1, so times 3 times 3. So I've got minus 30 minus 8, so I've got minus 38 over 3. Now I'm going to divide both sides, so times quarter times negative quarter and times negative quarter. Why? Because if I divide both sides by negative 4, dividing by negative 4 is the same thing as multiplying by negative quarter. So I've got k is equal to, negative and negative is fine, right? So that's positive. So I've got 38 over 12. Now what is 38 over 12? We can divide it by 2, divide by 2, so I get 19 over 6. And that's my answer. That's 3 and 1/6, right? 19 over 6 or 3 and 1/6. I hope you guys understood that. Don't forget to leave comments in the comment section below if you are not understanding. Alright, let's move on to question 15. End behavior. Okay, this is nice. What's the end behavior of the function f of x? Right, so end behavior means you got a value 0. End behavior is positive infinity and negative infinity. So what's happening when the graph is going towards positive infinity? When the graph is going towards positive infinity, I can see like there's an asymptote happening here, right? So limit as x approaches positive infinity of the function f of x, I can see this is going towards, the value is going towards 1, isn't it? Why? Because it's going higher, it's not going to touch that. There's an asymptote. So 1. Limit as x approaches negative infinity, this is the left end behavior, that's a right end behavior of f of x. And I can see when I approach the graph towards negative infinity, what's the y value? Is going towards 1 as well. Right, so this is also 1. So describe the end behavior. I described the left end behavior and the right end behavior. This is for the right. Okay, this is the right end behavior because it's on the right, okay, going towards positive infinity. And this is the left end behavior, is going towards the left. Alright, that's the left end behavior. I hope you guys understood everything. Right, thank you.